Novaya Zemlya Archipelago, Russia, October 30th, 1961. October 30th, 1961 seemed like just another ordinary day. In an ideal world, this video might never have been needed. However, at 10,500 meters in the air, a Tupolev Tu-95 was about to make this day historic, marking it forever as the day we created a second sun on Earth. The story of the hydrogen bomb is truly fascinating and fits into a time when the development of weapons of mass destruction was at its peak. Although the first nuclear bomb was based on nuclear fission, developed under the Manhattan Project during World War II, the idea of using fusion to release unprecedented energy emerged almost simultaneously. Enrico Fermi and Edward Teller were the first to suggest in 1941 that a fusion bomb could be triggered by igniting a fission bomb. At that time, there were still 4 years to go before the first nuclear explosion. As World War II intensified, various countries began investing in nuclear weapons projects. The Manhattan Project in the United States was the most advanced. During the same period, Edward Teller, whom I mentioned earlier, devoted much of his work in the Manhattan Project to the concept of a nuclear fusion bomb. At that time, the main challenge was making theoretical predictions and calculations to understand nuclear fusion. On the other hand, fission bombs like those used in Hiroshima were much easier and cheaper to test. Nuclear fission was well studied at the time, and there were methods to test it with reactors and radioactive isotopes. Meanwhile, nuclear fusion remained more theoretical, like a second version of the bomb. Now, I'm being a bit pedantic, but it's important to clarify. Fission and fusion are different processes. Nuclear fission generally starts with a heavy atom, like uranium-235. This isotope is unstable and seeks stability by splitting into lighter atoms. The key is in the mass. The mass of the atoms produced is less than that of the original uranium, and this lost mass is converted into energy. In nuclear fusion, the process is the opposite. We start with light atoms, like hydrogen, and combine them to form heavier atoms, like helium. When measuring the mass of helium and comparing it with the initial hydrogen, we also see a loss of mass, which is converted into energy. In summary, while fission breaks atoms apart, fusion combines them. Now that we understand the basics of fission and fusion, we can delve into how a thermonuclear bomb works. Thermonuclear bomb, H-bomb, or hydrogen bomb are terms for the same type of weapon, which uses nuclear fusion to generate immense energy. The main challenge in building a fusion bomb is achieving the conditions necessary for fusion to start. As the temperature rises, electrons are stripped from atoms, forming ions. Since atomic nuclei have positive charges, they repel each other. Therefore, we need to reach extremely high temperatures and pressures to overcome this repulsion and make them fuse together. The Sun achieves these conditions because it has a mass 333,000 times greater than Earth's, and consequently gravity, that pulls everything toward its center. To create these conditions here on Earth, the solution proposed by Edward Teller and Teller-Ulam was to use a conventional nuclear bomb as a detonator. Yes, you heard that right, using a bomb like those from Hiroshima as a trigger for a larger one. In the Teller-Ulam design, the bomb is composed of 2 or more stages. The first stage is a fission nuclear bomb, like those developed under the Manhattan Project, and its purpose is to generate the energy needed to initiate the second stage, which is a fusion nuclear bomb. The explosion of the first stage creates the temperature and pressure conditions necessary for nuclear fusion to begin. When the fission bomb explodes, temperatures reach around 100 million degrees Celsius. This energy causes the second stage, composed mainly of fusion fuel, to start releasing energy. The Teller-Ulam design is so efficient that it has become the standard for most modern fusion bombs. On November 1, 1952, in the Marshall Islands, the world witnessed the first real-scale test of a fusion bomb. The Teller-Ulam design needed to be tested, and the first fusion bomb, codenamed Ivy Mike, weighed 74 tons, making it impractical for real-world use. The fusion fuel, liquid deuterium, had to be kept at extremely low temperatures, requiring the development of cryogenic technology at the time. Nevertheless, the test was carried out. When the bomb exploded, it created a fireball 5 kilometers in diameter, and the mushroom cloud reached 41 kilometers in height, more than 4 times the height of Mount Everest, and spread to a diameter of 161 kilometers. The explosion created two new elements in the periodic table, Einsteinium and fermium. The test could have ended here, showing a bomb with 1,000 times more energy than the one used in Hiroshima, a tragic event in human history. However, the arms race continued, and no one wanted to show weakness. On October 30, 1961, in the Novaya Zemlya archipelago, northern Russia, a Tupolev Tu-95 was about to make this day historic. The Soviet Union used the same hydrogen bomb design tested 9 years earlier by the US to demonstrate its military power. Known as the Tsar Bomba, or the bomb of bombs, it remains the most powerful explosive device ever detonated. While the bombs dropped on Hiroshima and Nagasaki were in the kiloton range, and the first hydrogen bomb, Ivy Mike, was in the megaton range, the Tsar Bomba had an energy potential 100 times greater, around 100 megatons of TNT. However, the tested bomb had its potential reduced to 50 megatons of energy due to fears that a 100 megaton bomb could cause a nuclear winter. The fireball had an 8-kilometer diameter, and the plane that dropped it was 39 kilometers away at the time of detonation. Even so, the plane was impacted by the shockwave and fell uncontrollably about 1 kilometer in the air. The official survival estimate for the crew was 50%. The photograph of the mushroom cloud, taken 161 kilometers away, shows a cloud that reached 67 kilometers in height, more than 7 times the size of Mount Everest. The shock wave traveled around the planet 3 times, activating all the planet's seismic sensors. The flash was visible 1,000 kilometers away. Windows were shattered 780 kilometers away as a result of the explosion. Additionally, the test was so powerful and irresponsible that, due to the enormous explosion, the heat generated was sufficient to cause third-degree burns to people 100 kilometers away from the epicenter. The Tsar Bomba marked a chapter in history, being the most powerful explosive device ever used. Paradoxically, it also marked the end of the search for even more destructive weapons. After developing a weapon with destructive potential comparable to that of gods, the Partial Test Ban Treaty was signed, banning atmospheric tests of nuclear weapons. It would be naive and ingenuous to believe that the nuclear arms race truly ended in 1961. Much more powerful weapons have been developed by various nations since then. The nuclear age is still with us, and we need to hope that our representatives do not make hasty decisions in times of crisis. Our survival, perhaps the survival of humanity, depends on this. Thank you very much, and see you next time.